Algebra 2 7.6b, Word Problems, Formulas, and Radical Equations. Now we're up to 17 previous videos for Chapter 7, and if you haven't seen them and you become lost or confused during this video, my advice is to go in this description, click on the links of the previous videos, and catch up to find out what you missed. Okay? The formula v equals 1.2 times the square root of h is a radical equation that approximates the distance v in miles that a person can see to the horizon from a height of h feet. We can find a formula to approximate height, setting the formula to solve for h instead of that v. We can use the principle of powers and square both sides of the equal sign. We learned that in the last video. There's a link to that one in this description. And the principle of powers stated for any natural number n, if a equals b is true, then a to the nth equals b to the nth is true. The principle of powers is also called the power rule for solving equations with radicals. Depends on what textbook you have, okay? So we have v equals 1.2 times the square root of h, and we need to solve it for h. At what height in feet can a person see in the distance 72 miles to the horizon? So h is going to be in feet height or high, and she's sitting on this rock and she can see 72 miles away to this horizon. We need to figure out how high up she is, okay? So we're going to take our formula, v equals 1.2 times the square root of h, and we're going to solve it for h. We're going to isolate that square root of h by dividing both sides of the equation by this 1.2. That creates our buddy, the invisible 1, because the numerator and denominator are the same, right? And then on this side, we have v divided by 1.2. We square both sides of the equation using the principle of powers, and that'll remove that square root symbol. That'll remove that radical sign from the h. We end up with just h on this side, but on this side, we end up with v squared divided by 1.44, because 1.2 times 1.2 is 1.44. Now what we do is we take that 72 miles and we put it in the place of the v. We substitute it in. And 72 times 72 is 5,184 when we do the multiplication, see? We just divide this, and we find out she's 3,600 feet high. See? So all we did was we isolated the radical by dividing it on both sides by the 1.2. We squared it to get rid of the radical sign. We substituted in our numbers. We did our division, and we had our answer. See? That's not that bad, is it? Okay, let's try this one. Now, many useful formulas involve radicals or radical expressions. So here we've got a guy that's dropping something, okay? So the formula v equals the square root of 2gs represents the velocity, v, of an object that has fallen a distance of s feet, and the g is the acceleration due to gravity. So the first thing we're going to do is solve the formula for s and find s for a falling object with a velocity of 32g. We take our formula. It's already got the radical on one side of the equal sign, so we're just going to square both sides to remove the radical symbol. We end up with 2gs on this side and v squared on this side. We need to isolate that s, so we're going to divide both sides by 2g. That's going to change our formula to v squared divided by 2g equals s. Now we can substitute that 32 in there for the v. 32 times 32 is 1,024. We divide it by the 2g, and we find out s is equal to 512 g feet. See? Square both sides, remove the radical, isolate the variable, substitute in the numbers, do your division, and you've got it. Okay? Now this next one, we're going to talk about a Graaff generator, and I wanted to show you what one was before we got started so you could really understand and picture it in your head. This is a Graaff generator, and this is what's happening when electrical current is going through it. You can see around this surface outside, it's got this positive charge. You can see this little bolt of electricity coming through this thing. And actually, the electricity is going all the way through it. See the little arrows? And I don't know if you can tell, but there's actually little charges here. My picture is just too dark. I have a black and white laser printer, so it doesn't show it that well. Well, we know if this is a circle, kind of looks like a circle, doesn't it? We know going all the way across the middle here is the diameter, and half the diameter is the radius. Well, for this problem, it says the radius of a Graaff generator that can collect a maximum charge of Q coulombs on its surface is given by R equals 1.826 times 10 to the negative second power, that's scientific notation, isn't it, times the square root of Q. We need to solve the equation for Q and find Q for a generator with a radius of 1.5 meters. So that's a pretty big circle if this is 1.5 meters here, right? So we're going to take our formula here and we're going to isolate this radical, the square root of Q, to one side. So we're going to divide both sides of the equation by this 1.826 times 10 to the negative second power. Create a huge 1, because the numerator and denominator are the same. So on this side, we're going to have R divided by 1.826 times 10 to the negative second power. And on this side, we're going to have the square root of Q. And we're going to square both sides to remove that radical sign using that principle of powers. So now, because we did that, we just have a Q on this side. But on this side, this is what's interesting. The R squared, that's understandable. But why is the times 10 to the fourth up here? Well, we had a times 10 to the negative second. When you multiply negative 2 times negative 2, you get a positive 4. And that positive exponent 4 for that x to the 10th has to come up to the top because he's a positive, all right? So now we can substitute in the 1.5 for r. That's our radius. 1.5 times 1.5 is 2.25. And we do our scientific notation. 2.25 times 10 to the fourth power is going to move that decimal point 4 places to the right, which means we need a couple of zeros as placeholders, don't we? We're going to end up with 22,500 divided by 3.334276. That's what this is squared, okay? We do our division, and we come up with that Q is approximately 6,748.09 coulombs, because it wasn't exactly, it went 0.0910, something something. So I rounded it off to the nearest hundredth, okay? So what's a coulomb? Well, it's the International System of Units, which is SI. A coulomb is the International System of Units, unit of electric charge, transferred in 1 second by a steady current of 1 ampere. What's an ampere? That's a unit that's used to measure electric current. Then you start going into volts and ohms and stuff like that, and you can look that up on Google, right? So our next video is 7.7a, and we're going to talk about imaginary numbers and I. I'm going to put this video into the Algebra 2 playlist so you can use it to study. And the 11.9 video from Algebra 1 last year actually talked about radicals and equations. And I'll have links to Chapter 11 from Algebra 1 in here. And then I'm going to put all the links from Algebra 2 that we just did that can help you out. They're going to be in this video's description, so you can just click on them, okay? Those 17 previous videos are very, very helpful. And, you know, I've got my little sign here. It says it's easier to climb a ladder if steps aren't missing. So if you've missed some videos, you can still climb that ladder, but it's going to be really rough. It would be very easy if all of the rungs on the ladder were there, wouldn't they be? All right? Don't forget to hit the like button if I've helped you. And don't forget, I'm on patreon.com, and you can become a monthly patron. All right? For $1 or $2, you can help me out. I'll see you next video. Keep trying. I'm proud of you for watching math videos on YouTube. It's a trait of a successful person that helps themselves. Bye.